In this video, I will explain about bonds that hold atoms together within compounds. So I have drawn a bunch of compounds you see on the screen here, and we're going to talk a lot about bonds today. So again, thinking back to the picture of an atom, at the center of an atom is its nucleus, and on the outside of the atom are electrons. Those electrons can be shared between two atoms. So when one electron from one atom meets another electron from another, and their electron clouds overlap, it kind of creates like a handshake, and that holds those two atoms together. So the simplest example of that would be hydrogen gas, H2. So hydrogen has only one electron in its electron cloud, and so this solid line right here represents the two electrons that are being shared between these two hydrogen atoms. And we refer to this single line as a single bond. So single bonds are made up of, single bonds are two electrons. And a shorthand for electron is a lowercase e with a negative sign above it, because that electrons are negatively charged. So single bonds have two electrons being shared within those atoms. We also have double bonds, D-O-U-B-L-E, double bonds. And double bonds, an example would be in this compound here that's green. This green compound is acetone. So if you've ever used nail polish remover with acetone in it, that is what the chemical compound looks like. It is made up of one carbon, one oxygen, and two hydrogens, and they are bound in this way. Okay. Note if the hydrogen is bound off the carbon, right? Both hydrogens are bound off the carbon. If the hydrogen was bound off the oxygen, this would be a totally different compound. So the way that atoms are actually bonded together, it makes that compound unique. I could draw you another structure with this single hydrogen moved over here off this oxygen, but then that wouldn't be acetone. That would be something totally different. So it matters the way you draw things. But so double bond, so notice I have two lines between this oxygen atom and this carbon atom in the acetone, and that means that double bond has 4 electrons total being shared. So double bond is 4 electrons. And the last type of bond that you come across a lot in chemistry is the dreaded, it's not really dreaded, but the triple bond. So a triple bond has, for an example down here in this pink compound, this is acetylene. This is what acetylene looks like. You can use acetylene blow torches in welding if you're welding metals together. But there you can see right there the 3 lines, 1, 2, 3, and that represents a triple bond, which is made up of 2, 4, 6 electrons, right? Because each line represents the sharing of 2 electrons between those atoms. Sometimes in our structures, you'll see these dots, okay? And these dots are referred to as lone pairs, okay? Lone pairs. And those are just electrons that are not bound between 2 atoms, but they are just hanging out on the element that they are around. So a lone pair is also 2 electrons, right? So this nitrogen atom in ammonia, this is ammonia, NH3, nitrogen with 3 hydrogens bound, and it has 1 lone pair on the nitrogen. So this nitrogen has an extra set of electrons on it. And when we talk about drawing our Lewis structures in the next episode, you'll see kind of why that lone pair exists. You can also see lone pairs on water molecules, right? H2O, 2 hydrogens, 1 oxygen. The oxygen has 2 lone pairs, total of 4. And here is our image of our molecular drawing of carbon dioxide. So it's got a carbon in the center, and that carbon is double bonded to 1 oxygen with 2 lone pair, and it's also double bonded to a second oxygen with 2 lone pair. One quick thing about bonds, if you can spell honk wrong, like incorrectly, if you could spell honk, H-O-N-K, and C, right, honk as in honk a horn, if you can spell honk incorrectly and count to 4, 1, 2, 3, 4, you are going to have a pretty good time drawing our Lewis structures, because this explains the bonding patterns that you see between atoms. Hydrogen always has one bond to it. Oxygen always has 2 bonds to it, and you can see that 2 different ways. Like in water, oxygen, right, has 2 hydrogens coming off of it. But in carbon dioxide, it looks like this. But in either way, the oxygen atom has 2 bonds coming off of it. This oxygen atom has 2 bonds coming off of it, right? And this oxygen atom has 2 bonds coming off of it. Nitrogen has 3 bonds coming off of it, and normally you'll just see it like this, and it'll always have 1 lone pair on itself as well. And last but not least, carbon, the basis of all of our life, our organic matter, is carbon-based. Carbon always has 4 bonds coming off of it, always. Always, never 3, never 2, always 4. Now that could be in a couple different ways, right? You can have all single bonds, you can have a carbon that has 2 sets of double bonds, like in carbon dioxide. You could have, if we think about the carbon that we saw in our acetylene gas, right? Each carbon molecule in this acetylene gas has a total of 4 bonds coming off of it. But essentially, if you can spell honk incorrectly and count to 4, you can skip ahead and start organic chemistry. In the next video, I'll talk a little bit about how to draw Lewis structures, which is the rules behind drawing the structures that you kind of see that I'm drawing here.